Welcome back. Today, we are talking about a concept that is, no exaggeration, the backbone of almost every program you'll ever write: repetition. Let's jump right in. So, up to now, we've learned how our programs can store data using variables and make decisions with conditionals. But, what happens when you need to do something more than once? That's the real magic, and it's the piece of the puzzle we're adding today. Here's the game plan. We'll start with why loops are so important. Then we'll get into Go's super clean approach. We'll see how to control them, how to use them on real data, and finally, we'll cover some common mistakes to help you avoid them. So why do we even need to repeat things in our code? Well, because doing things manually is slow, boring, and honestly, a recipe for disaster. Imagine trying to process 1,000 user profiles one by one. Loops are what save us from that nightmare. So what is a loop, really? Think of it as a simple instruction. You're just telling the computer, hey, do this chunk of code over and over and over again until this specific thing happens. That condition is the key. It's what tells the loop when it's finally time to stop. You're actually seeing loops in action all the time. When you scroll through your social media feed, a loop is fetching and displaying each post. When an online store shows you a list of products, yep, that's a loop. They are literally the engine that powers automation. All right, let's talk about how Go does things. Now, if you're coming from other programming languages, you might be used to having a few different kinds of loops, like while or do while. Go decided to do things differently. And I think a lot simpler. That's right, just one. This really gets to the heart of Go's philosophy. Keep it simple, keep it clean. By having only one loop keyword, the for loop, Go gives us a tool that's incredibly flexible. It can do everything those other loops can, just without the extra keywords. This right here is the classic counter loop. It's the version you'll probably write and see the most. It might look a little busy with those semicolons, but it's really just 3 simple parts that work together to give you total control. Let's break it down piece by piece. First, we have the initialization. I equals 0. This sets up our counter. Next is the condition. I less than 5. The loop will keep running as long as this is true. And finally, the post statement. I++. This runs after every single trip through the loop, changing our counter so we don't loop forever. Okay, so we've seen the basic setup, but the Go for loop is way more of a Swiss Army knife than it first appears. You can actually adapt it to behave in a few different ways, which is what makes it so powerful. So Go doesn't have a while keyword, but you can get the exact same behavior. You just leave out the initialization and the post statement from the for line. Now it's just a condition. The loop will run as long as I is less than 5. But be careful. You have to remember to update I inside the loop yourself. And if you want to get even more minimal, you can leave everything out. Just the keyword for on its own creates a loop that runs forever. Now, an infinite loop might sound like a bug, but it's actually a really important tool for certain kinds of programs. Think about it. A web server's job is to run 24/7, just waiting for the next person to visit a website. Same for a background process that's always listening for a new job to do. These are perfect examples of when you want a loop to run forever on purpose. But okay, what if you're inside a loop and you need to get out now? That's what the break keyword is for. It's like an emergency exit. Here, even though the loop was set to run 10 times, the second I hits 5, break is called and the loop just stops cold. Now, what if you don't want to stop the whole thing, but you just want to skip the rest of the code for this one specific iteration and jump to the next one? For that, we use continue. In this code, when I is 2, the loop hits continue and immediately jumps to the next cycle where I will be 3. So let's make this super clear. Break is a full stop. It terminates the loop completely. Continue, on the other hand, just skips to the next lap. Understanding this difference is absolutely crucial for writing loops that behave exactly how you expect them to. All right, this next bit is one of my favorite features in Go, and it's something you will use constantly. When you have a collection of data, like a list of names or prices or anything, there's a beautiful, clean way to walk through every single item. And this is it, the range keyword. When you use it with a for loop, it does something amazing. On each pass, it gives you 2 pieces of information: the position of the item, which we call the index, and the item itself, the value. This is the go-to, idiomatic way to handle collections in Go. Okay, we've covered a ton of ground, but before we wrap this up, I want to talk about a few common traps that are really easy to fall into when you're starting out with loops. These are the big 3. Seriously. Forgetting to update your counter is the #1 cause of accidental infinite loops. Getting the condition wrong means your loop might not run at all, or it might run one too many times. And mixing up break and continue, well, that can lead to some really tricky bugs. And here is a perfect example of that first mistake in the wild. See what's missing? That I++ part is just gone. So I starts at 0, the condition I less than 5 is checked, and it's true. The loop runs, and then I is still 0. This will print 0 forever. And I really want this to sink in. This stuff isn't just theory. If you plan on building real software that does useful things, you are going to be writing loops all day, every day. Mastering them is not optional, it's essential. So let's just take a quick look back. You now understand what loops are, and more importantly, why they matter so much. You've seen all the different ways to use Go's single for loop, how to control it with break and continue, and how to use range to work with data like a pro. So I'll leave you with this challenge. Think about a project or an idea you have. What is the first repetitive manual task that you can now automate with a for loop? Thanks for tuning in, and I'll see you in the next one.